one of the 8 components and also one of the key players in the industry. GP New Energy is the first company that has reached kilogram scale mass production of fuel cell catalysts. And also today, Mr. Liu has also brought with us some new developments and research and development and application of the hydrogen market. And also, it has brought a lot of good news in this kind of development. So now we will have the Deputy Director of Shanghai Power Energy Storage System Engineering Research Center, Mr. Dang Guoju, to share with us the potential applications of PGM sensors in smart cells. I'm Dang Guoju from Shanghai Power Energy Storage System Engineering Research Center, and I'd like to share with you the potential use of PGM sensors in smart cells. I will share with you following the 4 aspects. The first one is lithium-ion batteries and its safety issues. And second, why does thermal runaway occur? And third is the smart cell built-in sensors. And the fourth one is its prospects and the development of smart cells. This is a list of all the lithium-ion related accidents in the past 2 years, be it energy storage, or scooters or EVs. There are some thermal runaway cases. It's mostly because it's high energy, high dense, so it has some certain safety issues that therefore thermal runaway often occurs. So it is a very important issue for us to improve the safety of lithium-ion batteries. For the traditional module-like sensors cannot answer this need, so we need new sensoring technologies. Only with this can we effectively resolve the challenges we are faced with. And also for the single batteries, with this kind of new sensing technology, we can detect the temperature field, strain field, air pressure, gas inside the monolithic body during the whole life cycle. And here there are pictures of all these accidents. Things caught on fire. Even when there is no oxygen in the environment, there will be big fire. Then why does thermal runaway occur? It's mostly because that they commonly use lithium-ion batteries still consists of the anode, cathode, and the membrane, etc. And during the operation, the temperature rise may cause a decomposition of the membrane, which will cause a short circuit. Then the anode and the cathode will be in direct contact, which will release big heat. And be it a cylinder battery or prismatic or pouch or cell phone batteries, there is a possibility for them to catch fire. And when the thermal runaway occurs, there is an indicator that is the rise of temperature and pressure fluctuations, gas release, and voltage changes. As the battery is in a sealed case, so there is a rapid increase of the inside pressure. A lot of thermal runaway, we mostly rely on temperature sensors. We connect the temperature sensor with the internal environment to predict the temperature rise. However, through this infrared camera, we can see that this temperature rise on the surface and inside the battery is unevenly distributed. So it is very difficult to precisely predict the temperature, as the battery may be placed in different places and we may be measuring different spots of the battery. So what we want to do is to build a smart sensor into this battery. However, if the sensor is built in, then there will be high requirements for the sensors. First, we need to avoid the impact of the inserted sensory on the electric circuit inside the battery. And also, we need to look for more stable materials to make sure that it can sustain this harsh environment. And also, it has to be compatible with the battery structure.
So here is a list of the development of such sensors. At the very beginning, they were separate and gradually they became simulated, integrated, and they became digital and gradually become smaller. They come in networks. So if we look at the principles of the thin film technology development makes such sensors widely applicable, including the gas sensors, because gas sensors currently are mostly used in aeronautics because they are relatively larger. So if we want to apply these gas sensors, we want to apply micro technology. We want to make them smaller with higher sensitivity so that they can be integrated and embedded in batteries. However, embedded sensors have lots of challenges and difficulties. The first is imprecise measurement, and second, difficulty in embedding them, and thirdly, not able to get the signals out. The first challenge is imprecise measurement because of the corrosive environment. It's very complicated, so the environment must be stable. And second issue is long-term stable cycle of the battery. In other words, after we get the sensors embedded, they cannot affect the performance of the battery. The thirdly, signals cannot be taken out if it's a wireless transfer of the signal because of the share of the batteries that keep the battery in a sealed environment. The signals cannot be gotten out. So the way we deal with is we have special sensor components to address the imprecise measurement issue. And second, we have integrated low damage integration process to address the second challenge. And thirdly, through modulation of signal, we overcome the shielding effect to ensure that signals are transmitted out. Well, what we did is back in 2010, there was a project team from the Institute of Science of China. They used some special materials that are rather stable, and they are more adaptable to the internal chemical environment of the battery. So they chose polyimide sheet as flexible sheet and as flexible substrates, and they get rid of part of the active elements, and they use electric insulation, and they created this sensor, and they have multiple points thin film sensor, and they relied upon the PCB and resistance acquisition system connection in order to record the various electric resistance at different points during the cycle of the battery and turn them into temperature signals. We did some testing, and we found that the precious metal sensors can do real-time measurement of the temperature change on the different current rate. And second, thin film sensors have limited impact on the performance of lithium-ion battery. And thirdly, even under bad battery conditions, for example, when the conditions are really bad, the precious metal sensors can be there stable for a long time. We also embedded a gas sensor. In other words, before runway of battery, there are various gases generated inside the battery, including methanol as well as other types of gases. So we have embedded gas sensors to measure the generation of such gases in order to provide early warning for the possible runway. Well, previously we relied upon wired connection, but we wanted to do wireless transmission or wireless connection. So what we did is we want to encapsulate the sensor module with the wireless transmission module inside the battery. So what you see is the battery. However, with wireless transmission of signal, we can see in real time the temperature and gases as well as changes in the process of cycle. With all these different data points, we do comprehensive analysis and to generate real-time early warning systems. As a result, before thermal runway, we have sufficient time to deal with whatever that might happen in order to avoid any damage to life or to property. So what we want to do is we want to design smart sensors. We want to design the battery in a way that all the sensors are integrated together and they're embedded in the battery. So these sensors can help us get information from mechanics as well as electro and from other types of reactions, including thermal and gas information, so that we get comprehensive collection of information to do assessment of the situation inside the battery. That way, we can do smart and safe management of the battery. In other words, we want to get a smarter battery, just like all the vital signs that you see from human. With all these sensor data, we will be able to have more smarter management of the batteries in order to prevent or minimize thermal runways. That's what we want to do. We want to have an embedded sensor early warning system inside a battery. In other words, before thermal runway, people have sufficient time to deal with any possible runway, or at least they have sufficient time to get themselves to a secure place. We also want to apply it to smart grid inside and outside the smart grid with the joint early warning system. We want to reduce any accidents with regard to the energy storage system. So much from me. Thank you very much.